Okay, welcome back to my YouTube channel, guys. Today we are going to be discussing centripetal force and centrifugal force, and we are going to be using two instances: artificial gravity and the roller coaster. So for artificial gravity, this is a spacecraft. Ignore my drawing. Spacecraft, and this spacecraft is actually being spun around or rotated, whichever one you want to use. And what we are trying to solve basically with this is weightlessness in space. So we have two forces here, which is the centripetal force and the centrifugal force, because it is being spun. Okay, so it's moving in a circular motion, and centripetal force is the force that keeps it moving in a circular motion. So it actually acts towards the center of the spacecraft. But for centrifugal force, it's not an actual force, it's a fictitious force. And what centrifugal force does is it acts outside. Yeah, it acts outwards. It's an outward force which acts outwards, essentially against the walls of the spacecraft. And what this force does is it creates artificial gravity and allows any object in the spacecraft to be attached to the walls of the spacecraft instead of just being weightless and in the middle. Okay, so now we're moving on to the next thing, which is the roller coaster. So for the roller coaster, we have two scenarios here. When it is when you're at the bottom of the roller coaster, when you're on top of the roller coaster. If you've ever been on a roller coaster, you'd notice that when you're at the bottom, you actually feel heavier than when you are on top of the roller coaster. Now this is because of the forces in play here. Okay, so we have two forces here, your weight, obviously, and then the normal to this force. And as I mentioned before, for objects to be able to move in a circular motion, there's a force called centripetal force that keeps these objects moving in the circular motion. So centripetal force is the force that acts towards the center of the motion. Yeah. So in order to maintain this circular motion, what we have to do is, when we resolve these forces, there needs to be a net force in the direction of the centripetal force, right? So you can create an equation from this, net force being equals to the normal minus the weight, and that is because we are taking the upwards direction as our positive y direction. Okay, so this would be the equation that you'd have. And from this equation, what we need is for the net force to be positive, showing that it is in the positive y direction, which is moving towards the center of the motion. And to be able to achieve that, we need our normal to be larger than our weight. And that is because, so it works out, equations. Thank you. Yes. So because of the magnitude of the normal here, it's going to be greater than the weight, you feel heavier. Because with this, with the roller coaster, your actual weight is not changing. It is simply a feeling of heaviness. Yes. So at the top, a similar thing happens. We have our weight, which is acting downwards because gravity, and then our normal, which is also acting downwards. Oh, no, yes, yeah, right. And centripetal force is always acting towards the center. So over here, you can see that all the forces are acting towards the center, or they are all moving in the same direction. And because of that, you do not need, your normal force to be bigger or heavier or greater than your weight, because it's all in the same direction. So it all caters for the net force of the centripetal force. So that's why you feel lighter on top, because on top of the roller coaster, the magnitude of your normal force, it's smaller than the magnitude of your normal force at the bottom of the roller coaster. Thank you.